To solve this question, let's first start by factoring out the greatest common factor between our x values. And I'll start by kind of rewriting our expression here. So now we can divide by the greatest common factor, which in this case is going to be x to the third. So we will pull out an x to the third. We're also going to pull out a y and a z, so I'm going to leave these there as placeholders, but we just don't know what exponent we're using yet. Then we can start dividing. So x to the fifth divided by x to the third. Remember, when we are dividing two numbers with like bases that have exponents, we subtract those exponents. So x to the 5 minus 3 would give us x squared left over, and then we would have placeholder for y, placeholder for z. I'll leave some space, and then anything divided by itself is just 1. So x to the third divided by x to the third will give us 1. Now I'll grab a new color and we'll go on to our y values. The greatest common factor between y squared and y squared is going to be y squared. So we will pull out that exponent, and in both cases, anything divided by itself is just 1. So in both cases, we just have 1 in our parentheses. Then we can move on to our z value. The greatest common factor between z to the 6th and z to the 7 is going to be z to the 6th. So we pull out that z to the 6th, and what's left over? Z to the 6th divided by z to the 6th will give us 1. And z to the 7th divided by z to the 6th will be z to the 7 minus 6, or z to the 1, which is just a regular z. Now we just need to simplify. We have x to the third times x to the 2, z to the 6th, times anything times 1 is just itself. So x to the second times 2 ones will just be x to the second, minus z times 2 ones will just be z. And that perfectly matches the last answer option, making that our correct answer.